Hey 8th grade, this is video 2 for your 8-3 notes. If you did not have your book open or the online textbook pulled up for video 1, you might not have seen what a hyperbola looks like. So here I have a very rough sketch. You'll notice that there's two branches. We have our vertical and horizontal asymptotes, and then your two branches are on alternate corners of these asymptotes. One characteristic is your A value. If it's greater than 0 or if it's a positive number, your branches are always going to be on the top right and bottom left. If your A is less than 0 or if it's negative, that means it's reflected, and your two branches are going to be on the top left and bottom right. So here's a better visual for you with guided practice 3 part A. Notice our A value is negative, so that's why our branches are on the top left and bottom right. And if you don't have that memorized while you're working through this, it's okay. If you do your table of values correctly, it'll fall into place. Your vertical asymptote is your H value, which would be -4. You cannot have -4 in the denominator because you would end up dividing by 0. So that's a restriction in your function. So that's where we're going to sketch our vertical asymptote. So just a nice straight vertical dashed line that shows that none of our graphs, neither branches of our graphs are ever going to cross x equals -4. And then our horizontal asymptote is going to be your k value, so that'd be a +1. So I did a nice straight dotted line here to represent our horizontal asymptote. And again, neither portion of our graph is going to cross that asymptote. And then from there, it's just a table of values. So you want to be cautious when you type them in your calculator, when you're using any type of calculator for your table of values. You want to make sure you lump your denominator in parentheses so that it knows that you're actually going to want two terms in the denominator. So since we have x plus 4, my graph that I drew went from +10 to -10. So that's why I decided to at least start there to see where my graph exits the coordinate plane that I have. So I'm going to start with -10. So -10 plus 4. Okay. And then I'm going to add the 1 off to the side. So now my calculator knows that this entire expression is in the denominator, numerator divided by denominator, and then I'm going to add 1. So I get 1.3 forever. Now I'm just going to continue to enter that. And since this is pretty spread out, I'm just going to skip around some values, and I'll go back and fill in if I need more. So I'm going to try -8, and that's where I get 1.5. I'm going to go back, enter -6, I get 2. So those are two really nice values that I can plot. Okay, so just to kind of save you some time, I went ahead and filled in the table of values for you. I have a gap here for where my asymptote's going to be. And these are going to be, they're not symmetrical, but they're going to be nice smooth curves. So they will look like if you were to fold these diagonally where your asymptotes cross, they're going to line up very nicely. So here's all the values that I got. Notice these values I included in my table of values because they're actually nice integers. And they start plotting nicely closer together. But as I go up closer to 10, I'm noticing there wasn't a huge jump from -1 to 0. So I just decided to jump to 4. If I wanted to go back and fill in the gaps, I could, but I already knew what the answer looked like when I made this problem, so that's why I didn't have to do that. And then again, since my graph goes to 10 for the x-axis, I went ahead and included it in my table. On your worksheet, you're not going to have that big of a graph, well, on future worksheets, quizzes, tests. So just do, my suggestion is just to do the two values that your x's do approach. So if it's just a 6, then obviously you don't want to go higher or lower than 6 and -6. And I have a note here. That's basically what I've been saying. So on this particular worksheet, it does look like I did go from -10 to 10. So start there with -10. Maybe leave a big gap and do 10, and then just start filling in the pieces in between. If this were a test and I were grading your graph for accuracy, I would expect to at least see these integers plotted. I would definitely want to see these halves, and then I'd want to see where they exited your graphs. Okay. Draw nice smooth curves. There's going to be arrows on both sides. Do not cross the asymptotes, but get very close to them, and there's your hyperbola. Okay, so then part B, you'll notice my table of values is much smaller. For this one, we have a little bit extra happening in your denominator, but that's okay. If we set that equal to 0, our h value is still just going to be positive 1. Our k value is going to be negative 2. Our a value is a positive. That's why these branches are on the top right and bottom left. So I'm going to draw my vertical asymptote at 1, my horizontal asymptote at negative 2, and then fill in my table of values. So here I'm starting with negative 10 and 10 since that's what my homework is telling me to use. And I'm getting some pretty close together numbers, which is telling me that my table of values could probably be pretty small as well. And as I just started typing in all these values, these all got really close together, but I needed to have some points to plot near my vertical asymptote. So that's why I included 0 and 2. I included the value that's 1 unit away to the left and to the right of my vertical asymptote, so I at least knew where I can start drawing my curve. Okay, and you want to be careful again with typing in your calculator. So for this one, we want to make sure we put the entire denominator in parentheses, which might cause an extra set of parentheses for you. And let's see, get it all typed and then we'll look at it. So here we have 1 divided by, and then here's my denominator, 3 times x minus 1. And instead of x, I put negative 10. Closed my entire denominator in parentheses, minus 2. And there's my value. Okay. So the number of points that you plot are going to vary as long as you can see from these two examples that you want to plot as many as you need to get as accurate of a shape as you need. If you're getting values that are all very close together, you only need to plot here. You'll see I only plotted 2 for each branch, and everything else is just going to get closer and closer to that asymptote. If you're not sure, just try more points. If they don't seem to fit or if they seem like they're unnecessary to plot, you have them in your table of values as a way of showing work. You don't have to plot them on your graph. And that wraps up 8.3. Tomorrow we'll do the first part of 8.4 where we're going to learn that there's many other shapes that these can take as well. If you have any other questions that this did not assist you with, make sure you email me and let me know so I can help you.